Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. Thank you for having me in this first international conference on science, engineering and technology 2021. I'd like to say my appreciation first to organizing committee from Mir Chakar Khandrin University, Pakistan, especially to Dr. Wakas who invited me into this conference. So in this conference or in this talk, I will talk about the current status and future direction of waste to energy conversion technology and how we are going to achieve a new balance. A little about myself. I'm currently working as a technology advisor for CM Technologies Canada, and at the same time working at Institute Technology Bandung, Indonesia as a researcher and lecturer. My research area is related to waste to energy conversion, biofuel production, catalyst synthesis and its application, and also the bio-based product development. In this talk, I will briefly discuss few phenomena that shape our world today and for the next decade, such as industrial revolution, sustainable development goal, and megatrends. And on the second part of this talk, I will show a few of the technology that we can use for waste to energy conversion. One of the things that changed our world is the Industrial Revolution. The Industrial Revolution is a transition to a new manufacturing process from home industry to cheaper mass production in more efficient way. So this was started by the invention of the steam engine in 1700 and then followed by other inventions such as Stirling combustion engine and others. And currently, we are in the middle of the fourth industrial revolution, which normally called IR 4.0, that consists of technology, fusion of technology, automation, IoT, and other advanced technology. So IR 4.0 is basically disrupting almost every industry in every country. And it transformed the entire system of our production, management, and also governance. As the fourth industrial revolution continues to evolve and disrupt existing social and economic system, the future of work will increasingly be defined by the use of digital technology. It will simply replace human in few sectors, but creates more opportunities in many. Unfortunately, the industrial revolution has damaged the environment, and we will continue battling the climate change unless we change our way of life. So in many places we experience extreme weather, water problem, sea level rise, and also affect the yield of our food harvest. So we definitely need to change. So fortunately, many of the world leaders has committed to the Sustainable Development Goals that was proposed in 2015 to address the global challenge we face. That's including those related to poverty, inequality, climate change, environmental degradation, peace and justice. Another thing that we have is basically megatrends. So these megatrends are global. It's a large social, economic, political, environmental or technological change. It's normally slow to form, but definitely affect many aspects of our lives. So it's going to impact the business, economy, society, cultures, and personal lives. So thereby, it's going to really shape or define our future. And luckily, a country like Pakistan and Indonesia, it's considered as emerging and a growth leading economies. So based on the fact that we are a big market and we also have a lot of natural resource. And then we have a COVID-19. So this is basically totally changed our world. It's really affect our productivity, and then the oil price collapse. You can see also suddenly we shift the way, we change the way we work, and then new business model which is closer to end user is suddenly growing very fast. So this is really affect the way we think about our future, our business, how we're going to do everything in terms of education, for example. It's really changed, and it's going to open also another opportunities, of course. So in here, I just want to highlight a few growing area in engineering based on what happens today and in the last few years. So we're going to see a growing area in food industry, clean energy. Definitely it's something that's going to grow steady and constant. And then of course in terms of waste conversion, management and treatment, it's also something that it's going to grow quite big. And then we have bio-based product, electronic industry, healthcare industry, pharmaceutical industry. So basically in many industry, this is going to grow, and it's going to open a lot of opportunity. Before we discuss about waste to energy conversion technologies, I'd like to show you a little bit about the world energy consumption, how it changed in terms of renewables. From 2012, for example, in here that we've seen, in 2019, you can see that it's still dominated by the fossil fuel, which is 85% comes from oil, coal, and natural gas. However, when we look at this graph, we can see that part of the renewable energy it has steady growth, and some of the fossil fuel like oil and coal, basically it's going down for some time already. An interesting prediction has been done by an organization called DNVGL about the energy transition timeline. So currently we only have about 19% of the energy is non-fossil, and this basically includes all the renewables and biomass, and it is predicted that the use of oil will peak in 2022, which is a year from now. So it's going to start declining, while non-fossil share will constantly increase for the next 3 decades. So by 2033 or 2033, by 2033, it is predicted that the energy demand will peak and then decrease due to energy efficiency. Now let's talk about the waste, especially the municipal solid waste. Believe it or not, that the waste that goes into our landfill is still dominated by organic waste, which is about 50%. Sometimes it's over 50%. And food is basically the largest part of it. So in a country like Pakistan, I think in Indonesia, I think about 30% of our waste that goes to landfill is basically food. This is the data that shows how much the food that we waste every year. So this is the data per capita in terms of kilogram per year. So based on this, the Food and Agriculture Organization of United Nations, FAO, estimates that each year we basically waste about 1.3 billion tons of food. So this is about 1/3 of all food produced for human consumption in the world. So this is of course include all the fruit and vegetable, fish, seafood, all dairy products and meats. And not surprisingly, most of this wastage is occur in developed world. In Europe, for example, and North America, they waste about 95 to 115 kilogram per year. So this is compared to about 6 to 11 kilogram in sub-Saharan Africa or Southeast and East Asia. So unfortunately, this is basically happening everywhere. Ironically, even when we spend or we waste about 1.3 billion tons of food, there are still about 820 million people do not have enough to eat today. So this thing happened basically all along the supply chain from the production stage to final household consumption. This is a good chart that shows how we basically waste the food for different types of food. For example, in here you can see the types of grains, roots, oil crops, meat, and different type of food. So it starts from the initial quantity, and then we're going to lose it some in the agricultural stage, on the post-harvest processing, and then the distribution and also the consumption. So basically, in average, we lose about 30% of the food. So we really need to think about this circular economy. So in circular economy, the value of product and material is maintained for as long as possible. So we try to basically minimize our waste and resource, and then we try to keep our resource within the economy, and then when the product reach the end of its life, we can use it again to create another product, or can be used further to create value. So this is to show how we think about the waste, and this is for example, let's try always to prevent it first, and then to reuse it, and then recycling it, and then as our last resort is basically to recover using waste to energy conversion technology, and then of course the last one is to do the landfilling. For example, if we try to prevent the waste, we can always just, for example, borrow things, or perhaps swap it, share it with each other or with our neighbor, and then when we go up a little bit, we can do composting, for example, for our food waste, and of course we can also do recycle. So doing all of this, it's going to reduce the waste that going to the landfill. However, we will always end up with residual waste. So what we have to do with this residual waste, the option is, there are two options. So either we try to convert it into energy using the technology that we have, or at the end we have to do the disposal into the landfill. This is the charts basically that's showing how the European country is leading the way to do the waste to energy conversion and also the recycling. A country like Sweden, for example, Denmark, Germany, and then Finland and Norway, basically the top country that really put the technology for waste management, either to waste to energy conversion and also the recycling. And I think this is something that we can also do in our part of our world. For example, in Pakistan, in Indonesia, in Southeast Asia, for example, I think this is something that we can always follow. So how we trying to perform this waste to energy? So the concept basically is to have a waste segregation first, and then we're going to have a waste collection for different type of waste, and then, for example, all the organics or anything that has potential to be converted into energy will go to waste to energy plant, and then over there we are going to produce fuel, for example, and then we also produce gas that we can use for heating, and also we can create the electricity. So what kind of process that we can use to perform waste to energy conversion? So I'm trying to focus here more into the organic waste and also the biomass, for example. So we can do chemical conversion, or we can do biochemical conversion that involve microorganism, or we can also perform a thermal conversion, which is more destructive and probably the last choice for the process that we will choose. In order to understand the process, how we choose the process, we need to understand first about the source of the waste or the biomass waste. So we can have a different type of a biomass source or waste. It can be from forestry products, for example. It can be from the waste from agricultural crops. It can be from household waste, animal manure, or from water, and also industrial residue. For example, if we have a biomass like a lignocellulosic feedstock, so we can use different type of process to convert this feedstock into something more valuable or into energy. You can use gasification, for example. You can use pyrolysis and torrefaction to produce fuels and different kind of specialty chemicals. And then we can also use different type of process such as fermentation to create sugar or alcohol, for example. In terms of chemical conversion, we can do different type of process like esterification, extraction, or some reaction to upgrade a certain type of waste. For example, in here you can utilize waste cooking oil or automotive waste or from oil and gas, and you can produce something that like biofuels, biodiesels, and several chemicals. Of course, we need some kind of expertise in kinetics, chemical process, and also the material science. And then, as I mentioned before, we can also choose the biochemical conversion. So this include the anaerobic and aerobic digestion. You can basically convert different type of waste such as algae, municipal solid waste, agricultural waste, or industrial waste, or even from the farm, like animal farm. Right? So the product can be in terms of in the form of biogas that you can use for electricity and heating. You can also produce biofuel and chemicals, and of course you can also produce some high quality fertilizer. Again, in here we need the expertise of chemical process, kinetics, and also the material science. And then of course the last choice will be thermochemical conversion, because thermochemical conversion is a process that where you need some heat. You're heating it up into certain temperature. For example, in torrefaction, you're probably heating it up about 200 to 300 degrees Celsius, and then for pyrolysis roughly around 500 degrees Celsius, and then for combustion and gasification you normally use temperature about 800 or even up to 1000 degrees Celsius. So it's quite destructive, and it's not easy to control the product, but basically you can pretty much throw everything into this type of process. Any kind of waste, when you use torrefaction, it just converted into kind of a biochar or like a carbon active, for example. When you use pyrolysis, you will turn it into bio oil or biofuel and chemicals. And then for gasification, from his name, I think you can guess that it's going to produce gas such as hydrogen and CO, that you can use it to as a building block for different types of chemicals. Before I end my presentation, I'd like to show you a few successful examples of waste to energy conversion, such as biogas plant facility, waste to energy conversion, and also the other waste to energy conversion technology. This is an example of a biogas plant in Ukraine that has an output of 5 megawatt hour. And this is a typical example of a biogas plant that normally operated within a palm oil plantation. So it used the palm oil plantation waste and turn it into electricity. And then in terms of thermochemical conversion, we have one company from Canada, for example, here, that tried to convert softwood into a bio-crude oil that you can mix it with petroleum crude oil for refinery. And last but not least, there is an example of a waste to energy power plant, which is Fanta Energy, that has an output about 78 megawatt of electricity and also about 120 megawatt of district heating. With this, I end my presentation for now, and I want to say thank you everyone for your kind attention.